Hi everyone, welcome back to my channel again. So as you guys are already aware about my advanced rack playlist, so in the last video I have already discussed about a very basic thing about LLM, a high level idea I have given to you what is LLM, how it works, as well as I have shown how you can connect with multiple LLM provider companies using LangChain. LangChain is a framework that you can use to build your GenAI applications. Okay, and in this playlist we are going to talk about LangChain as well as LangGraph, which is another framework. Okay, so in the last video we discussed how we can connect them using LangChain using OpenAI and Olama. So today I will show you another LLM provider company. That's not an LLM provider company, but they mostly focus on inferencing. I discuss about inferencing and all. So there is another company who provides the same thing. Okay, and I will show you that, and that's also for free. So today I am going to discuss about that also when we will do the practical section. Now what are we going to discuss today? So today we are going to discuss about problems with LLMs. So as I discussed in the last sessions that LLM can answer all of your questions, but still there is some concept called RAG, right? So what is RAG and everything we discuss, but before that let us understand what is the problem we have into LLMs and why suddenly RAG comes into the picture, right? So let's start. So here in my screen you can see LLM. I just kept ChatGPT logo here. So what your LLM can do, guys, it can talk in multiple languages, it can write stories for you, it can solve your coding problems, right, etc, etc. It can do. Now what it cannot do, it does not have new information, guys. Sometimes it guesses, that we call it as hallucination. Okay, so this is the problem in LLM. Okay, your LLM does not have new information about the market. Okay, if I just tell you why, because it was trained on internet data till some specific date. Like here I kept one screenshot. You can see OpenAI's GPT-5 has already been released and was launched on August 7, 2025. Okay, and this model is fully trained on and is available to all ChatGPT users, including those on the free plan. Okay, so it was launched on August 7, 2025. Okay, now the thing is this GPT-5, GPT 3.5, whatever models you know, those models are trained on internet data and till some specific date. Okay, so that is why whatever data where they are inside the internet, those all were used inside that LLM. But what about new data? What about today's data? LLM does not have that kind of information there. Okay, so that's why RAG come into the picture. I am again going to discuss more about it, but let us start with RAG first. So I have given you a very high level idea that why we need RAG. Okay, so now let's talk about it. So what is RAG? So in RAG, A means augmented, G means generation, and R means retrieval. So what we are doing here, we are giving access of some different documents to our model or to our LLM so that it can answer. Okay, now I'm going to discuss about why RAG. So first you can see here, LLMs have a fixed knowledge cutoff. They can't know anything after the training data date. So LLMs were trained on internet data and those data were there till some specific date, right? So on some specific date only this OpenAI company trained that model, correct? Now that is why it cannot know anything after the training data date. The next thing is LLMs hallucinate. So they confidently generate false information when unsure. So if you are asking any recent regarding any recent information, right, your LLM may not have that answer because it was trained before that date, right? So sometimes what happens, it confidently generates false information when it is unsure, which is not right. Now next, LLM cannot cite or reference sources, so it's hard to trust the response without evidence. So LLM does not have the real time information, right? So sometimes it may give you some answer, but there is no trust in the response, there is no proof in the response, right? It might be wrong, we are not sure on that aspect, right? So there's another thing, private organization and data is not part of training. So LLM don't know your PDFs, manuals, or internal documents. What does it mean? So your company may have some private data, and you are not going to share your company's private data, right? And those data are not available on the internet. So if your company's data is not available in the internet, then how LLM will access it, right? They cannot train their LLMs on those companies' data, right? So that is why RAG come into the picture also. Next is training LLMs frequently is costly. Updating a model requires huge computational resources. So as I said, your LLM has trained on some specific date, right? So now upgrading one LLM is not an easy task, guys, because you need a huge compute to train one LLM. So frequently training an LLM is not a very easy thing, and it is very costly, right? Now real world use demands dynamic knowledge. So data changes, product specifications, policies, prices, news and research, right? So daily your data is changing. Today your product price may be $100, tomorrow the product price might be $150, right? So daily your data is changing. So if we really want to use LLM in a real world use case, so it always demand dynamic knowledge that we have to provide, right? And another one is better domain specialization. So RAG or RAG lets model answer specific industry questions accurately. So these are some list of reasons that we can use while building RAG. Okay. Now let me talk about naive RAG pipeline. So guys, there are a lot many RAG types. Those are there. We are going to discuss about them in future sessions, but right now we have to understand our naive RAG first, how it works, then we discuss further. So let us start with data. As I said, in RAG we need to pass some data because our LLM doesn't have information about real-time data or our company's data, right? So now what kind of data we are talking about here? Anyways, I am going to show you one very simple example next time, but let's talk about now. Data means simple, guys. It's about some PDF document, let's say, or some text document you have. Okay, that's the data right now in a scenario. So what are we going to do? So what we are doing, we are first reading our data or loading our data. After loading the data, we are dividing our data into multiple chunks. Chunk 1, chunk 2, chunk 3, chunk 4, chunk 5, chunk 6. Why we are dividing into chunks? We are dividing into chunks because our LLM has a limitation on context. Okay, our LLM can read some n number of context. Okay, there should be some size, like based on different LLMs they have different kinds of context length, but they have a limited length. That's the thing I wanted to say here. So that is why if you have a big data, right, if you have a very big PDF file which has 1000 pages, let's say, or which has 10 pages, let's say, so feeding all 10-page content into LLM is not possible because its context length will exceed for sure. So that is why what we do, based on our LLM's context window, we try to divide our data into multiple chunks or multiple pieces, you can say. Okay, so right now you can see, if you assume that in my case I have some text document and my text document contains some specific text in it, and what we are doing here, we are dividing that data into multiple chunks. Okay, right now for example I have shown you 6 chunks here. Okay, so next what we do, we are trying to embed those each and every chunk. Okay, and when we are embedding that, so let's say we have embedded each and every chunk. So right now we have 6 embedding of those each of the chunks. Okay, so after that what we are doing, we are storing this chunk of data in a DB or database, and in RAG scenarios we use vector databases. For now you can think vector database is like a database where we store our embeddings. Okay, that's what we are doing in DB. So this is the very basic pipeline of RAG, but it's not yet completed, guys. I will discuss more next. Okay, now let me explain to you the same topic with some data examples. So right now, let's say you have a text document. In a text document, you have this kind of information that I am Tanmay, I am basically from India, I am working as a data scientist, I have 4 years of experience in this data domain. So let's say you have a text document, and your text document contains this data. Okay, now what is going on? So first step, as I said, I have to read my data and I have to divide it into multiple chunks. So these are my chunks, if you see. Okay, so you can see it has divided my data into multiple chunks. So in my first chunk I have I am Tanmay. In my second chunk I have I am basically from India. Then I am working as a data scientist. I have 4 years of experience in this data domain. If you focus, guys, few cases I am actually repeating my data. See, here I have written I am working as. The next I have written working as a data. Then again I have written working data scientist. I have 4 years. Then I have written here 4 years of experience in. Then experience in this data domain. Why we are doing that? So see, guys, when I show you the practical, you will better get it. But just for your context, so when we actually chunk our data, what we do, we provide two things. One is chunk size. Another one is chunk overlap. Okay, so chunk size means what? I want to mention that what should be the size of my each and every chunk. That's what I provide. Right now you can see there are multiple chunks, right? Now each chunk has their own length, right? And chunk overlap we pass that how much you want to overlap. That number also you need to pass. So that is what is happening here, guys. Here I am working as, okay, and working as a data science, or only working as a data, right? So this only working as a data is overlap here. So working as is there in the previous chunk as well as in the current chunk. So that's what overlapping happening here. And why we do overlapping? We do overlapping because if we do not do overlapping, our LLM may get confused based on the context that we are going to give it, right? So if we keep some overlapping in our chunk, so LLM always gets some extra information so that it can better answer. So that is why we provide chunk size as well as chunk overlap. Okay, so next what we are going to do, simple, we are trying to embed our each and every chunk. So right now you can see I have kept some example embeddings. So these are my embeddings of each and every chunk, right? So you guys may know about embeddings. Embedding is nothing but we are converting our text into numbers so that our models gets it, right? So that is why we convert our text into numbers. So same step is done. Now what I am doing, simply I am storing these embeddings in my DB or database. That's what is happening here. Okay, guys, now let's talk about how it works as a user perspective. So what happens behind the scene when we develop RAG? So let's say you are an user here. So you are asking some question. And what is the question? Some random question you are asking, right? So whenever you are asking some question, first what is happening? First we try to convert our query. I mean whatever query we are asking, we convert that into embedding. Okay, so we are trying to convert our English query into query embedding. Again, converting text into number. Once you are done with that, what we do? We try to do a search on the DB, because in my DB I have stored my data or embeddings, right? So now what will happen? Whatever query you have provided, those query converted into embeddings. Now these embeddings will try to search into the DB and it will try to find out which chunks are matching or closely matching with the query embedding. Okay, so after that, once it is done with the search, what it will do, it will give you multiple chunks. Let's say it has found 3 relevant chunk 1, chunk 2, chunk 3. It has found 3 relevant chunk that is closely matching with the query embedding from the DB, right? So now what is happening next? We are providing the prompt and query and this relevant chunk into the LLM. So right now LLM is having 3 kind of information. One is prompt, another one is query, another one is those relevant chunks. So what is happening here? Prompt means I am telling my LLM how you behave while answering the question. Then query. Query is the question that LLM has to answer, and these relevant chunks are the references for the LLM, that when you answer the user query, you try to refer this chunk and answer. So now what is happening, your LLM may not have the information that is related to this document, but right now what is happening, your LLM will have the context of the document with some relevant chunk, so it can refer the relevant chunk, the prompt, the query all together, and it will try to give you the response to the user. Okay, now this is the flow, how it works, the naive rack pipeline, guys. Now in this naive rack pipeline, we are going to understand which part is rack, I mean which part is R, which part is A, and which part is G. Okay, so if you see this highlighting section, right, this is the R section of it, that means retrieval section of it. Why retrieval? Because here what we are doing here, we are trying to convert our query into embeddings, we are trying to search in the DB, and we are trying to get the relevant chunk, right? So what we are doing here, we are retrieving this information that we need from the database, right? So this is the R or retrieval part of it. Now next, A, that is augmented part of it. Why augmented part? Because now what is happening here, my LLM is getting three information, right? Prompt, query, and the chunk. So now LLM can augment all of it and give us the response. So that's why LLM augmenting things. So this is why this section we call as A or augmentation. Okay, and this is the last section, which is G, generation. So this is why LLM generating it, right? So right now, based on the prompt, chunk, and query, LLM is going to generate the response. So that is why this section is G. Now after the generation, you will be see the response, right? So that's why it is R, this is A, this is G, retrieval augmented generation. Okay guys, now let's see some other examples so that you will get it far more better way. Okay, okay, now let's say my query is who is Tanmay. Okay, I am going to ask this query. This is my first step. Now what is happening, we are going to do this search into the DB, and you know in my DB I have this data, I mean not this data, it has chunk of data, right? But this is the data that I trained in the last PPT. So in my DB it has this data only. So now what is happening, so now when it will search, let's say the question was who is Tanmay. So once this query is given, and when it goes to the DB and tries to find the relevant chunk, it may get this three information, that okay, based on the user question, I got this three relevant chunk. These chunks contain I am Tanmay, I am basically from India, data scientist, I have 4 years, okay, experience in this data domain. Now what is happening, so we are providing prompt. I said right in the last PPT that we were providing prompt, query, and the relevant chunk. So right now this is the prompt, guys. So as I said, prompt means we provide information to the LLM that how you behave while answering. So that's what information I'm giving here. You are an AI assistant, you need to answer questions related to Tanmay's career. So this is the prompt I am providing to my LLM. Okay, now what is happening, LLM is generating the response, and the response is Tanmay is a data scientist, he has 4 years of experience. Now LLM doesn't have the information about Tanmay, right? So what has happened here, I have given my information to my LLM so that LLM can answer questions related to it, right everyone? I hope you have understood the whole naive rack pipeline, guys. So now what we are going to do, we are going to implement on naive rack using LangChain on some same text data, so that you get the real world practical example of it, then how you can implement it. So let's start that thing also. Okay, now let me start with the practical of RAG here. Okay, so first what we are going to do, I have created one Jupyter notebook here in my VS Code, naive rag -nb file. Okay, so now what we are going to do, first before starting I am going to going inside this requirement.txt, and I am providing some library names. Okay, some library names that I am going to use. Okay, so LangChain text, sorry, LangChain text splitter, LangChain classic, LangChain experimental, LangChain OpenAI, LangChain Grok, LangChain community. So these are the libraries that I am going to use in today's session. So that is why I am installing this library inside my environment. Okay, so as you guys know already, in the last session we created some environment and we created our app, right? So today also we are going to do the same thing, but right now we are going to do for RAG now. Okay, so let's go ahead. So as you know guys, to install everything I have to run this command pip install -r requirements.txt, and my environment is already activated. If it's not activated for you, you please activate it. Okay, so yes, so now my code will run and it will install all the dependencies that is required. So I can now go back to my notebook and I can start implementing it. Okay, great. Now what is the first thing I'm trying to do, guys? First I have to connect with my virtual environment. Okay, it's connected now. So what we are going to do now, simple, I am going to import few libraries from LangChain community document loaders, import text loader. From LangChain text splitter, import recursive text splitter. Okay, so this text loader will help me to load some text document, and this recursive character text splitter will help me to chunk my data. In the next lecture we are going to discuss about different chunking methods with some detailed example, guys, but for now you can assume that using recursive character text splitter you can chunk your data. Okay, okay, so what is the data we are talking about today, guys? So let me tell you about the data also, so that we can discuss about it. Give me a second. Okay, so now I am going to drag the data that I am downloading right now in my another screen. Okay, okay, what I am doing here, I am copy pasting my data. So what I am going to do now, I am going to create a new file here, details.txt. okay, and inside this details.txt I am keeping some text information. Let me see what kind of text information. Tanmay is a dedicated forward-thinking data scientist with over 3 years of professional experience in transforming raw information and all, so on and so forth. So it has some information about me. Okay, so this is the txt data that we have. So on top of this data I am going to build my RAG. So as you know, LLM does not have information about me. Okay, so what will happen, it will try to answer questions from this data only. Okay, okay, so as you have pasted this line, so I'm just executing this code. Okay, so we are good with our code execution. So next what we need to do, we need to load our data, right everyone? So to load the data I have created one variable loader. Okay, loader, and then I am calling text loader. So inside the text loader what I need to do, inside the text loader I have to pass the document path or the file path. So right now my file path is this. So I can simply type details.txt. If you simply pass details.txt, you can execute this code. This loader.load will load the document. So if I now run doc, see, it has loaded my document. See, this is coming in a list format, right? So what is showing? Document, and it has some metadata also. See, it has some metadata about the source file, about the page content. It has the page content. So this page content is containing the actual data, and this metadata source detail.txt. So it is hosting the metadata as well as the actual content. So this is the document that we read right now. Okay, so as you know, the next step is we are going to chunk, right? We are going to split or chunk our data. So that is what I'm doing right now. So in the I have created one variable splitter. Inside that variable I am calling recursive character text splitter, which help me to split my data or chunk my data, right? So as I said in the PPT session, right, that we have to provide the chunk size and the chunk overlap. So this is the thing, guys, I am saying the chunk size 100. So my each chunk or each split size will be 100, and inside the split we will have 50 characters as an overlap. Okay, 50 character as an overlap in my document, and this splitter, the split document, is going to split the document. And which document has to split? It has to split this doc, that means this what we load right? What we have loaded just a minute ago, that is what we are passing in the split document. So when I execute this code and when I call new docs, if you see new docs and execute this code, see it has actually splitted my data. And see, this is my split, right? So it has multiple split, guys. And see what my first split contains. Tanmay is a dedicated forward thinking data scientist with over 3 years of professional. See, it has only till professional. Now next chunk, see, scientist with over 3 years of professional experience in transforming raw information into. So now what is happening? In this context, I have few of the data, and in this context, I have some previous context as well as some new context. So now when LLM will get this prompt, it may get confused what professional I am meaning here. So if it gets these two chunks together, that okay, over 3 years of professional, then scientist with over 3 years of professional experience in transforming raw information into. So if it gets this two chunk, let's say, so it can better answer the question because it has full context or full information, right? So that is why we do the chunking here. Okay. So once you are done with your chunking, as I said, what we need to do, we need to convert our text as well as query into embeddings, right? So right now our data is there, so new docs contains the chunk of it, right? So now what we need to do here, we need to convert each and every chunk into embeddings and store them into some database, right? So for that I am importing OpenAI embeddings. Okay, so this OpenAI embeddings will help you to create embeddings right now. Okay, so right now I am just trying to put the OpenAI API key in front of you guys. So this is not a good way of doing it. You should keep that inside your environment variable, but right now I am not doing that. So, and this API key, please guys do not try to copy it, because after this recording I will definitely delete this API key. Okay, so you will not be able to access it. Okay everyone, yeah. So this is the embedding that I am defining here. So my embedding is defined here. So what I need to do, I need to now push my data into some database, right? Now let us do that. Now to push my data into the database, what I need to do, I need to call this chroma. So from LangChain chroma, import chroma. What is chroma? Chroma is a vector database where we store our embeddings. Okay, and I think I haven't installed chroma yet, so I am going to install chroma, and I'm adding that inside my requirement.txt file, and I'm just executing this code. So if I execute this code, it will now install LangChain chroma also in my environment. Okay, great. So now what is happening? From LangChain chroma I am saying import chroma. So apart from chroma, there are other more libraries are also there you can use, that we discuss in the future sessions, but right now I'm using ChromaDB as a vector database in our scenario. Okay everyone, fine. So what I'm doing here, from LangChain chroma import chroma, and then I'm saying chroma.from documents. I am providing chroma.from documents. I am passing the documents, that means these chunks I am passing. Then embedding, I am passing this OpenAI embedding, and I am saying persist directory equals to data. So what are these values? First of all, I have to pass the chunk, which chunks I want to embed, right? That I have to pass. Then embedding, that means using which model I try to embed things. So I am trying to embed it using OpenAI models. So that's why I'm providing OpenAI embeddings. Okay, so there are different kind of embedding models provided by OpenAI, provided by Ollama. So we are going to discuss about them in detail in the future sessions, but right now you can assume that you can use OpenAI embedding and you can embed your data, okay, or chunk. So right now we are embedding through that. Then you have persist directory, that means inside the data directory it should save all the data. So if I execute this code, it will take some time to execute, so let it execute properly. Yeah, it has executed things properly right now. So you can see one data folder is created, and inside the data folder, see, I have chroma SQLite 3 file. So this contains the information, guys. Okay, so now what we are doing here, we are calling the LLM now. So as you guys know about it, I am calling from LangChain OpenAI chat OpenAI. Then I am saying LLM dot chat OpenAI. I'm saying the name of the model and I'm passing the API key. So this is the LLM that we are going to use in our case. Okay, so you have defined our LLM. So our LLM is defined, our chunks are embedded, right?
So now what I'm going to do, I'm simply importing few libraries again. So I'm importing from LangChain core dot runnables, import runnable parallel, runnable pass through, and runnable lambda. So what is this runnable thing? I will discuss about it in further session because it has a lot to discuss. So just for your context, let me clarify what is going on. So if I really show you the prompt, okay, so this is the prompt right now that we have, right? So what is going on in the prompt? So as I have already mentioned in the PPT section, that we need to pass the prompt, the query, and the context. Context means what? Context means the relevant chunks that it will be fetching from the DB based on the query embedding, correct? So that's what I'm doing here. What I'm doing, I'm saying prompt template. So I'm saying you are expert assistant. Your job is to understand and answer question related to Tanmay. Based on your knowledge, answer the following question. And this is the placeholder that I am passing here. And then I am saying based on the context. So here the question will go, and here the context will go. And context means the relevant chunks, right? So I have mentioned that also, that if you get any questions other than Tanmay, you strictly mention that you answer a question related to Tanmay and nothing else, right? Now in the prompt section, I am passing two input variables, question and the context, because these are the two things I need to pass, right? And in the template I am passing the prompt template, okay, and I am execute this line. And if I execute this line, now you will see the prompt, right? This is the prompt, how it looks like, right? Okay, now we are coming back to that chain again. So right now we are building the chain, okay? So what this chain is doing, it is a one runnable parallel. Again, we will discuss about runnable parallel, runnable pass through, runnable lambda. But for now, you can think it like it is a runnable that is trying to pass this input parallelly. Okay, you can think it like that. But obviously, we will discuss about it in detail in further sessions about this runnable thing, what these things are doing in detail, so that you get the context. Okay, but for now, what is going on? So this is the runnable parallel, and this is the context. So whenever user will hit the query, when user is going to hit the database or hit the chain, it will take the input, right? And the input is the question. So this runnable pass through will automatically take that input in the question section, and based on the question, it will parallelly try to get the context using the DB or vector database. So this will give the context or the relevant chunk as a context, and the question, it will be saved here. Okay, and then the prompt that is already attached with the chain right now. So this context and the question, the prompt, the LLM, and string output parser will go together. So this is a chain I have defined here. Okay, they all are connected right now. So what this str output parser thing? So whenever LLM will give us some response, we need to see the response in string format, right, in a proper clean string, because sometimes LLM may generate one answer in some other format, right? So that might be confusing for the end users, or might be confusing for me as a developer. So what we do, we are saying use string output parser. So whatever output LLM will give, you just convert that output in a proper raw string format so that anyone can read it. So apart from str output parser or string output parser, there are other output parsers are also there that we discuss one by one. But today our goal was to show you how you can build a naive rack. Okay, so that's what we are focusing on today. Okay, I guess our chain is also ready. This is the retrieval chain I have prepared. So now what I am going to do, I am going to invoke my chain. That means I am going to hit my RAG, right? So see, I am hitting like this, retrieval chain dot invoke, and I am asking one question. Tell me 1 plus 1. See guys, I had already mentioned in the prompt that you are only answering question related to Tanmay, nothing else. So this question is completely different than very different than Tanmay, right? So if I ask this question now, that tell me 1 plus 1, you will see it will tell you I answer question related to Tanmay and nothing else. So even though you ask tell me 1 plus 1, it won't answer you, because as you have given the prompt that you have to behave like you have to always respond back regarding Tanmay's topic, nothing else. So if I now ask one question, let's say what is Tanmay doing? If I ask this random question, or what Tanmay is doing, currently, if I ask this question, just hit it. See, it is saying, I am sorry, I can only answer question related to Tanmay based on the context provided. It seems Tanmay is currently working as a data scientist and is known for his analytical mindset and problem solving attitude in the field of artificial intelligence, and so on and so forth. So based on my data, my question, it is answering me. Now guys, again, this was a very naive relaxation, and in reality guys, trust me, this is a very small prompt that I have written here. In real time cases, you may have to write a very bigger prompt because your RAG won't be that easy to do, right? You will have different scenarios, different use cases. You may have to write a bigger prompt with a lot of instructions so that your LLM can behave properly. So if you really want to make your LLM behave properly, you have to write a very good prompt. You may have to write each and every detailed prompt so that your LLM try to maintain all kind of aspects. Though it was a very basic session regarding RAG, how you can build your first track, that's what it's like that. But definitely further lectures we are going to discuss about how you can write proper prompts, as well as we are going to discuss how you can deploy something, because till now I haven't shown you the deployment yet. I will definitely show you in further lectures, as well as we are going to do projects that will be like production deployment level RAG projects we will be doing once we are done with the RAG architecture, RAG types and everything. So I think so I forgot to discuss about one thing, that is regarding Grok. So I told you already that there is something you can use for inferencing, I mean so for faster inferencing. Let me discuss about it. You just go to Google Chrome and search Grok. Okay, GROQ, Grok. You search Grok, you will find this page. Grok is fast and low cost inference. So this is a Grok page, how it looks like. You just click on start building. Okay, and I just logged in into their portal. That's why it by default log me in. But if you are a new user, you have to log in using Google. You can easily do the login using Google. Okay, so what is this thing is all about? So Grok tries to hold a lot many open source or free models. Now the problem that we had in Ollama, that is Ollama was hosted in our system. So models were there in our system, right? So sometimes it takes a lot of time for generating the response, right? So that is why instead of Ollama, you better use Grok, because Grok provides you faster inferencing. So you just hit your LLM, it will give you the answer in a faster manner. So that is why you can use Grok. Okay, so as you can see, Grok has a different kind of model for different kind of purposes. Like for reasoning, they have GPT OSS 120 billion parameter model. They have GPT OSS 20 billion parameter model. So guys, you can see the numbers. This number means these are parameters. This many parameters they have. So right now I am just interested more on text to text based models, because I have text questions, I want textual answers. So that's why I may prefer these models. So right now I would like to prefer this Llama 3.3 70 billion model. You just click on that and try to copy the model name from here. Okay, try to copy the model name from here, and you need to generate one API key. How you can generate that? Simple, just click on the API key section. For me there is API key given, but for you it will not be there. So what you have to do, you have to click on this create API key, give any random like I am giving right now, any random name, and just click on submit. If you click on submit, it will generate one API key for you. So I am copying this API key here, and what I am going to do, I am just going back to my code. Okay, and now what I am doing here, I am importing something from LangChain Grok, import chat Grok. So like we are importing for OpenAI, LangChain OpenAI, import chat OpenAI. Here you are importing from LangChain Grok, import chat Grok, right? And then I am calling chat Grok in the LLM section. then I'm passing the model name that I copied from the documentation and the API key. Okay guys, so see, as I have already mentioned, we do not pass API key like this. We always maintain that inside the environment variable. But right now I am not showing you that, just for your just for the faster execution of codes. Okay, so yeah, so now I have the LLM ready. If I execute the LLM, you will see it will show me chat grok model. Okay, and it has maximum input tokens, maximum output tokens. It is showing up. It's saying image art inputs false. It cannot take image input, audio input, video input. It cannot take this. It cannot give you image output, audio output also. So these all things are mentioned, that what it can do, what it cannot do. Okay, so fine. Now same code guys. So now LLM is now a chat grok LLM. Okay, and this code will be the same code, and I just execute this code to see the speed. See, it will give me the response again. Same question I am asking. What Tanmay is doing currently? So it's showing based on the provided context. It appears that Tanmay is currently working as a data scientist and blah blah blah. So same thing it has actually mentioned, and answer was quite faster, right guys? Because they are providing you faster inferencing. So that is why you should know how you can use Grok, so that you can do your POC so quickly. You don't have to wait that your Ollama takes time in your system. If you do not have highly configured system, you can use Grok as an alternative for now. So I hope guys it was quite useful for you. I think this is what that we have here. Okay, so today I think I had this much for you folks. If you really enjoyed this video, feel free to like this video, and don't forget to subscribe my channel, and please share this playlist with your team or whoever is interested to learn about RAG, advanced RAG, LangChain and LangGraph. Okay, so I guess then we are good to close this session. So thank you guys for watching this video. Have a great day ahead. Bye.